Let's start the part 2 of this uh, intermolecular forces session. We talk about the three different types of intermolecular forces, the dipole-dipole, London forces, and the iron dipole forces. So we already talked about the dipole-dipole forces. They are relatively stronger. They are actually about 1 to 4% strong as strong as a covalent bond. Next, we'll talk about the hydrogen bonds. Hydrogen bonds are also categorized as under dipole-dipole forces. They are, but they are stronger than the regular dipole-dipole forces. Look at that. Yes, they are as strong as 10% of a covalent bond. The hydrogen bond, the hydrogen bond occurs between hydrogen and a highly electron negative atom like oxygen, nitrogen, or fluorine. The HF, HO, and HN bonds are very polar. So in this very polar uh, hydrogen bond, the hydrogen is polarized as a delta positive plus, and the other element it will be polarized as negative. So this charge is not as simply as like we can. It is not a negligible amount. It is a considerable charge because this the other element of the hydrogen bond is highly electronegative, therefore this bond is highly polarized. So the when it becomes when it is close enough to another molecule where this hydrogen the bond between these two molecules, the attraction between the X and the attraction between the hydrogen occur as a hydrogen bond, the intermolecular force. The intermolecular forces occurs in between these. The HF, HO, and HN are known as the hydrogen bonds, and these are very strong. They are relatively stronger than the regular dipole-dipole forces. Yes, they can be occur between the ammonia and water molecule. Look, here this has a nitrogen, and here is a hydrogen of the water molecule. Yes, here is that the hydrogen bond. Yes, the hydrogen bonds can be occur between the same type of molecules or different types of molecules when the hydrogen and oxygen or nitrogen or fluorine is make a close contact. Here you will see a graph where we'll see the impact of the hydrogen bond. When we compare the boiling points of this group, only the hydrogen bonds occur between the ammonia, HF, and water, H2O. Only these three have a higher or a higher boiling point than this methane, because only these three have the hydrogen bonds as their intermolecular forces. Again, from the same period, H2O has the highest boiling point. HF has the highest boiling point than the other hydrogen halides. Ammonia has the highest boiling point than the other uh, members of its group.